Okay, construct, runtime, and tests. So actually, these two topics are very related. I mean, some of you have already seen, and we've been doing inside of the live exercises, that we've been doing tests, right? And in part of doing tests, we've been modifying this mock file, right? The mock file really is a mock runtime. Remember that the palettes you create don't make sense on their own. You cannot test a palette in a vacuum, right? Your palette is dependent on things like frame system. It's dependent on configurations of your constants and of your types. It's dependent on working within some kind of larger system, right? Like you can't just test a palette and say, okay, I want to reserve some balance. You need to have a balances palette. You can't have a palette say what block number is it. You need a system palette to actually do it. So the combination of these two ideas of how do we construct a runtime, right? And then how can we use that runtime for testing, right? In the context of the mock is one mock runtime. Usually it's very simple, usually uses very simple types, very few palettes, meant for unit tests, right? But of course, then you go to your real runtime, you use exactly the same tools to construct your real runtime, right? So that's the kind of idea here, that the testing and the real world is basically the same thing. But the advantage of these palettes being configurable and generic, right, means you can actually create a test environment much more simple to use for a unit test than the real environment. And one simple example there is we've been doing inside of some of the examples, whenever I have a user account, I just pick a number, 0, 1, 2, 3, etc., right? That's because I configured the system palette to have a UC4 as account ID. In a real blockchain, you would never do that. You would have a public key of 32 bytes. How annoying would it be? You have unit tests. You have to generate these 32 byte addresses every time and manage them. So the idea of, again, having this configurable, modular, extensible palette framework, runtime framework, allows for better testing, easier testing, whilst not compromising anything about the actual final runtime, okay? So that's kind of the story I would like to tell in this presentation, and I think it'll hopefully be enlightening, okay? So first, runtime construction. So as we talked about, our runtime is composed of these different palettes, right? So the construct runtime, or the runtime construction, is basically taking all these palettes, putting them together, making them concrete, gluing them together, and making it work. That is the idea of constructing a runtime. So in the end, your runtime is just a WASM blob. It is really just one giant program, right? But of course, how we architected it in the background is a bunch of individual palettes working together. So how do we construct this runtime, right? So the runtime is really two things. It is a struct, that runtime struct, that implements the config of all palettes, right? And it's a type that helps executive implement all the different runtime APIs. But I think this is the most relevant here, this first point, that your runtime struct implements all of the configurations of your palette, okay? And we'll see that more here. So we build a runtime using construct runtime typically twice. We use it first in the mock runtime, used for testing, right? And a real runtime somewhere else. So if you actually go into your project folders, you mostly been working inside the palette. But if you go, there's a runtime folder, and you'll see a construct runtime with all of the different configs exactly the same. And it looks very similar to the mock, but just more fleshed out. So what does the construct runtime look like? Well, it's a macro. And you can see here the construct runtime creates a public struct runtime. Okay, and then has this the different palettes included inside of it, right? The name of the palette, that's you decide, and the crate of the palette. Now I want to mention here, this is macro magic entirely. This is not real Rust. You cannot define a struct like this, right? Doesn't work. But the macro magic in the background allows us to do a bunch of things here, and you'll see different use cases of construct runtime. I want to note that this is, let me see, how do I say this? I would love for this to be more like Rust. Remember, one of the goals of Substrate was to be as rustic as possible. Inside of the palette stuff, you see we have these attribute macros on top of regular Rust objects, right? I would love to eventually see this also turn into that. But for now, with this special kind of macro, we can just write whatever garbage we want here. If the macro can understand it, we can handle it, okay? But this is macro magic. Your Rust analyzer isn't going to understand what's going on inside of here, okay? Yeah, struct runtime and all the things. Okay, so the runtime type, it implements a lot of stuff. And you can know all the stuff it implements when you do the cargo expand. you search for all the things impl on runtime, it is tons and tons of code that you don't have to write. We write for you. But most importantly, one of the things you will see explicitly in your code is that each config for your palettes is implemented for the runtime. So if you go into your mock, or if you go into the main runtime, you will see impl my palette crate config for runtime, right? So in each palette, there's this trait config. We expect it. It has your associated types. It has all your configurations. And of course, to actually configure it, we implement that trait for this runtime struct. So there's one struct that has all of the data on it. Okay? So if you want to know what is the balance type, the runtime struct can tell you that information. If you want to know what is the configuration for the maximum length of a vector, the runtime struct will tell you that because all of the different palettes are configured on the runtime struct. The runtime struct is an object that holds all of the implementations. Right. So then, anywhere in your palette where you have this tconfig, you can actually replace it concretely with runtime, right? So whenever you're writing tests or you're writing code inside of your palette, it's all generic, right? It's all generic that there's some T object implements config for my palette, and some point later you're going to understand what it is. That T is runtime. That T that implements your config is the runtime. So inside of your tests, you might remember that we used, instead of the word runtime here, it was test, remember? Test was the actually let's actually just go through this real quick, just because I think that this is a really good clear connection here. So I'm going to pick a random palette. I'm going to go to the mock. Remember the construct runtime? It creates a struct. In our most examples, it's called runtime. In test, we call it test. Right? So again, if it's easier for you, you can change this word to runtime. But there's an object test, which we are building all of the things on top of. In here, it's runtime. And so whenever you actually call and actually do something concretely, you pass that object, which implements tconfig, right? And therefore, you can actually do it. So in all of your tests, that's why you need to specify not T, but test, right? Because it is the object which implements the config. It tells the object concretely what to do. But again, in your palette, you're working in a generic world. So you're using the T as a generic. So I guess, it's kind of different. One is a generic type. One is the concrete object which implements the traits needed for that generic type, okay? But you can see here, inside of your test or inside of your real runtime, you call frame system, palette, pass in the runtime, which implements the config, and then call your functions. And this will work perfect, right? This is what we've been doing inside of the tests. You can do that for account. Any of the functions exposed by palettes, you just need to pass in the concrete runtime, right? Defining how exactly it should work. Let's take a quick pause there. Any questions on this? No, good. That's great. That's great. I think that this is as straightforward as you can see it. Okay. So going back to construct runtime, we have a list of palettes, right? So the palettes are broken into two parts. It's a name you choose. This is your name. And remember, this name is important because if you change it, it's breaking for a blockchain because it's used in storage. Remember? The hash function. So, it's not often a palette name changes, right? But don't choose something that you'll be embarrassed about later, right? And then, of course, a path to the crate. So you just link to the crates right there, right? Yes, and that's construct runtime. Oops, sorry. Did I click this? Yeah. Under the under the hood, this is generating a bunch of stuff. So when you have this construct runtime, if we actually do cargo expand, we will see that it will create for us a bunch of type aliases, right? So for every single name of our palette, we'll create a type with that name, and we'll make it equal to the crate palette with the runtime, right? So exactly if you do cargo expand, you'll see this for everything. So basically, we've created a bunch of aliases for you to access that palette directly, already configured with the runtime. It's just something that's kind of nice, right? You just, rather than writing all that, you can just access DPoS, right? And again, it works because we can put runtime in each of these because runtime configures the config for all of the palettes. It works in all of the cases. Which means, rather than even having to write this long line block number, you can just write system block number. Whatever the name you gave inside your construct runtime, there is a type alias which gives you easier access to this function, right? So again, just something that makes there is no difference between these two lines. It's just looks nicer. It's more easy. But I think you saw it when I was writing stuff. I wrote things explicitly to help you guys understand. There's not to hide the magic. But now that you know the magic, you can use it, of course, right? Okay. The next thing that the construct runtime does, which is kind of important for you to know, is we create this tuple of all palettes. Now, this again is hidden in the background, but you have access to it after construct runtime generates this code. And this is using executive to do all the hooks. So remember, we said in the hooks that you can create an onInitialize on each palette, right? How does the onInitialize actually get triggered? Well, we have a tuple. It has a list of all of our palettes in it. And then one by one, we go onInitialize, onInitialize, onInitialize on the tuple. We are actually iterating over the tuple and just calling onInitialize each one. So every single hook that our palettes expose, this all palettes tuple allows us to basically access all the palettes and then call the function we want. And exactly that. So somewhere in executive, you'll see, and we can look at it maybe, if someone reminds me, that they'll be actually using this object, all palettes, and we do onInitialize on each one of them. And I think there's a little bit of like macro stuff happening here that actually supports accessing it on the tuple, right? This is not something that's super easy to do, but you can imagine if this tuple, where every single object implements onInitialize, there's some way I could call that function on all the objects, right? Another thing to note then also is that the order of these palettes is the order that the onInitialize happens, right? So actually the order that you register the palettes in construct runtime could affect the logic of your code, right? Does that make sense what I said? The order in which you make the palettes could affect the logic of your code, like which one happens first, because the order is happening from here. Okay? You can imagine a piece of code where if you do it in the wrong order, it's off by one or it's missing some information or whatever, right? Okay.
So
a question, yeah.
Order by the index now, right?
The order is yeah. I think I'll show them more the specific index. Man, how do you? What's going on here? It's jumping around. Okay. Yeah, the order. There's a slide on the order. Okay. Okay. So there's a bunch of other things that are generated. I already gave a talk on this outer enum, but you know now the construct runtime is generating these outer enums for you at the runtime level, right? It's actually collecting all of the calls, events, origins, etc., and making an outer runtime call, event, origin, etc. The construct runtime is doing that for you, right? So that's one of the functions that it is doing. Okay. So yeah, I mean, we already went over this yesterday, but basically here's an example again of the call, right? So we create in our palette a set of calls which are Rust functions. Okay, the palette call macro is turning that into an enum. Okay, the function still exists. The function is still in the background, but we need an enum in order to help us do dispatch logic. And if you want to understand dispatch logic better, the Rust state machine actually makes you do that process, right? But we want to be able to dispatch to these functions, so we need to have a representation of all the functions out there. And you can see we make basically a call where we match the name of the function, the name to the name of the enum variant, and the parameters of that function are the fields of that enum, right? Minus the origin. The origin we don't include because every call has it, right? So we can handle it a different way. But from this we get to that, and then finally inside of our runtime call we aggregate all of those calls, right? So yesterday when I gave the example of how do we actually input a call into the parameter, I'm generating this call enum, right? Of course I can't really pass a function. I mean, I guess there are like these function attributes, but I'm using the call enum as the representation of which call I want. And then I handle dispatch to dispatch that to the correct logic, okay? Okay, so we've been showing you the construct runtime in just this simple form, right? It's basically like name and the crate. But actually, you have access to more low-level control. So you can see here, this is a more explicit way of defining a palette. You can put the palette name, and you can see here a bunch of the fields inside the palette. So you know your palette has a storage, has a call, has a palette struct, has a config. You can actually define which one of these things you want to import, right? Now, this is kind of an older syntax. This is what you probably want to use most of the time. But knowing the syntax exists, you can do some interesting things. For example, if you want to add a palette to your runtime, but you don't want anyone to be able to call it, you can define your palette like this, but exclude the call item. And then construct runtime will not include your calls into the call enum. So by default, we include everything. But if you want to, we can choose to not include some pieces that you don't want to include. Okay? But again, for all of you, this is just showing you that it can be done. For all of you, just do this syntax, right? What the worst case scenario is you forget to include something, and then you're banging your head, why is something not working, right? That's more scary for me, okay? So omitting them will exclude them from the metadata and exclude them from the outer runtime types, etc. Okay. Now indexing, we're talking about order, right? We also showed you that you can do, oh, geez, I hate the way Keon does these things. Sorry, it's like when I do left and right, it skips the whole section. Index, okay. We showed you before that you don't need to include any index. The index will be implicit on the order here. So this is 0, 1, 2, etc. But for the same reasons we index into the extrinsics, we allow you to index into your palettes. So if you want this one to be palette 0, you can index it 0, then index this 1, index this 2, right? And you'll notice inside of runtimes like in like Polkadot, we say like all the system palettes are like 0 through 20. And then all of the governance palettes are like 21 through 30. And we might not even use all the indexes, right? But we allow for some space if we want to add more palettes in the future, that they're kind of clumped together, right? But what's important is that this index is a breaking change. That if you change the index, it changes the encoding of the call enum, right? And that could be a breaking change. So having this explicit index is good for production runtimes, but it is not a requirement for this macro. It can automatically index it, right? But if you're making a production runtime, you should just use the index so that these things don't break without you expecting it, right? Okay. And I believe this syntax is just Rust syntax. Is that right? Like with the enum, you can do like equals and the index, okay? So this is just Rust. Kind of, because this text is not, but that syntax is Rust. So final thoughts. The order in the construct runtime matters. Recall, integrity test is called in construct runtime as well. So when you do cargo test on the crate which has construct runtime, all of the integrity tests will be run on that object, right? And so you'll get all the validation there. Yes. Oh my God. So Keon, thank you, Keon. You're amazing. If you want to be a macro magician, you can generate I would love for someone to contribute to be able to create a construct runtime that looks like this, because this is all real Rust, right? This is like legitimately real Rust, right? Your Rust analyzer can figure this out. Your Rust formatter can figure this out. It just requires someone to program it. Like, these macros, I mean, they're kind of heavy. They're doing a lot of things in the background. It just takes time to like find someone who can actually, parse in their head all this stuff and then generate the code that generates the code. But, it's just one programmer is away from making this happen. I think this is also more pretty and will help future developers understand this stuff better, right? We've done this work for all the palette macros. Construct runtime is lagging a little bit behind, but this would be an amazing, amazing way to do it. And also, it would be much more explicit, right? Like, remember the all palettes type was generated automatically for you, right? You never saw it. Wouldn't it be amazing that you actually see an all palettes here, and then you can know, hey, there's an object being created, which is this thing. This allows us to not hide as much, magic from you. So this would be better. Okay. Any questions on construct runtime? Yes, please. There's a mic up here in the front.
So I have a couple of questions. First, you mentioned that we can connect pallets partially. So can you just provide this example when we don't need a call? So you said
Right.
like we can.
So uh, okay. So if you had asked me, I want to launch a blockchain, but I don't want users to transfer their balances yet. Right? Because maybe there's some like setup period where I don't want users to be transferring balances, but I want to start building blocks, checking things work. There's a few ways you can solve this problem. One of the ways could be emitting the call. Right? It's probably not the best way. I prefer call filters, but one way would be emitting the call. Another thing you could do is imagine this. Imagine you want to build an amazing NFT game, right? You want your backend to that game to be the NFT palette, but you don't want users to ever actually call the NFT palette. You know, in this context, you're using the palette just as a backend, and actually you'll be creating maybe a tightly coupled palette, which actually wraps the NFT palette and has all of your gamification and all of your entry points, right? What you could do is you could add the NFT palette to your blockchain. You could remove the call, so it's not callable, but then add your palette with the calls, and then all of the calls to the NFT palette will go through your palette. So these are just some examples for why you might want to omit something. Again, there's nothing inside of Polkadot that does that, but it is an option that's available.
Okay. It's kind of optimization, right?
Optimization,
You don't connect all the parts of the palette. You just.
I mean, again, that's the thing. When you say optimization, there's some kind of speed up. I don't think it's optimization. I just think it's a configurability to you as a user, right? So,
Okay.
yeah,
And another question which I had is about integrity test.
yes.
So is it possible, I don't know, just maybe naive, but is it possible to configure integrity test to check the unsafe code inside of the palette? Like
Sure.
unsafe unwrapping?
Not
No?
not no no no. So it doesn't work that way. So I would love to create an integrity test for you here in class. So why don't we do that after in the first coding live coding? Remind me, and I'll make a very quick integrity test. It's not going to be able to catch things like unwrapping in your runtime, but it could help with unsafe code. For example, imagine somewhere you have um you have a vector, a bounded vector with objects in it, right? And your code assumes that vector is not empty or is not zero, right? Length, right? If you let the user configure the number, they could put zero, right? And then you could have code which assumes that it's not zero and you minus one or you index into it and that would panic, right? That is unsafe code. Your integrity test could ensure that config is at least greater than zero, which could then protect your code. Or you could assume it needs to be at least greater than 10 whenever you index into 9, right? So in these contexts, you could check that. But you can't check like, oh, there's this branch arm with this code and here's unsafe. Like, it doesn't work that way. A unit test could check that. An integrity test is more checking basic configuration and sanity check or constants are what you expect, okay? But I would love to give that example. So if you remind me, I'll just do a quick one. Okay.
So in this palette indexing, does the order of index depends also on the order of the code? Like the way system is having index 1 and balance is having 0. So can it be like balance can go up and then system be
Yeah.
down?
Balance could be the very bottom item, and you put index 0, it's index 0.
Okay.
So like imagine it gets reordered.
reorder. So there's no problem with the ordering of the
No.
code, right?
Yeah, so exactly. So when the ordering here is the default ordering or is the default indexing, but if you put the index, then it ignores this ordering and uses the index ordering.
In our project, we have the construct time in the main runtime that includes all the sub projects, and we also have the construct runtime in the mock for testing. So this we should leave this as it is, or should we remove the projects that we are not?
Yeah, I mean, if you want to remove it, you can remove it. It makes you feel better, but
Yeah.
they're not affecting you, right? They're all a bunch of test example stuff.
Yeah, empty stuff.
Yeah, so basically,
Yeah.
I included all of them because, I want you not to be banging your head 1 hour before the due date. Why won't this thing build? So, and one of the things I try to do always is I give you a fully building solution, right? So, at any point, if your build breaks, that was a you problem.
But the usual flow to build a pilot, would be to create a runtime as you did with like empty stuff, just a single palette, and then the part of the palette that you are developing, right?
Yeah, I think so. I mean, so like for example, inside of the Polkadot SDK, we have a one of our runtimes here, which is like the node. I think it's called the kitchen sink, and it has in it every single palette built into it. So where's construct runtime? Construct runtime. It has like literally every, like, look at this. Oh my god, dude. It has so many palettes in it. So as a part of, if I'm a palette developer in a company like Parity, I build my palette, I work on it, whatever. I create my mock, but then I also include it into this super runtime to make sure that everything is kind of working.
Okay, got it.
Yeah, okay. Any other questions about construct runtime? Yeah, by the way, if you ever want to include another palette into your runtime, which again, you should, I've been asked a few times, you should not need to include any other palettes than the ones I gave you into your runtime. You do not need to add democracy, you do not need to add whatever, you don't need to add, you're expected that your code should just be able to, you should be able to write all this stuff. Now, if you want to add it, that's good. If you think that adding someone else's palette will save you time, you are wrong. Because you not only need to understand your palette, you need to understand someone else's palette. It's not that easy to just grab a palette and then just like use it. You need to actually fully understand how that palette works. So truthfully, the best solution for all of you is to just write the code that you want. But if you do want to use another palette, and it is totally okay as an advanced scenario, you can go into this runtime, this node runtime, and it has a configuration implementation for every palette there, right? So you can copy and paste it to get a basic sanity implementation, right? So if you ever wonder, okay, how do I configure this or how do I do whatever, all of those configs are here in this file. Is that okay? Okay. Any other questions? Okay, so now we're going to go into testing, okay? So now we have an idea of how to construct a runtime. Testing is all about constructing a mock runtime and then testing it and then running unit tests against it, okay? So a test requires a mock runtime, so we do a full construct runtime inside of the mock. But luckily, most types can also themselves be mocked very simply. So inside of testing, most often you'll see that we use a U32 for account ID, that we use a U28 for balance, a U32 for block number, etc. You can basically make things simple. But definitely, this one's most interesting here, where an account ID would never be just a U32, but for testing, it makes it easier. If for whatever reason, maybe one of you is building a custom signing thing, right? Obviously, in this case, you could maybe not use this, because if you wanted to test that I can support Ethereum signatures or whatever, you might actually need to use the Ethereum address type as your account ID, right? So your unit tests also depend on the assumptions you have of your runtime, right? Does that what I'm saying make sense? Let me see, I'll say it one more time. Yeah, one more time. If I'm making a palette which requires some behavior of an Ethereum address, right? When I make my mock runtime, it doesn't make sense to use U32 because my code depends on this being an Ethereum address. U32 is not an Ethereum address, right? If my code is just saying I need some identifier for an account, it doesn't matter what the identifier is, but I can just give them money, U32 is perfect. That's an easy identifier. But if you expect some behavior about a public key, right, then you need to actually update your mock to use a public key as the account ID. So all of that is up to your control. For most of these palettes, or I think for all the palettes, you should be able to be fine with this. But you can imagine how you could create a palette which has more low-level assumptions about that account ID type, right? And therefore you need to do it. Okay. I'm going to give one more example here. I want to say a problem that could occur, but if it doesn't make sense for you, it's okay. A lot of these different projects, you generate an account, right? You're generating an account with some balance. If you're generating an account where the first bytes of that account is some like string, right? And then there's a bunch of extra bytes which actually determine like the uniqueness of that account, you can imagine problems with U32 because the first bytes will always be the same, and if it only fits 4 bytes, then you're not going to have unique accounts. Does that make sense? So usually you want to use like a hash function, right, to hash something so that all the bytes are unique. But you can imagine how you have a collision of 2 accounts if you're generating them weird. Now, if this doesn't make sense, no problem. But I'm just giving you, hey, there's some kind of weird behavior where 2 accounts are conflicting or whatever. It could be because of this, okay? Anyway, no problem there. We just forget that was ever said. All right. So testing. We want to supply some values to all the different get configs inside of our stuff. So inside of our palette, we have this config. Inside of the unit tests, we want to be able to actually configure these constants for our stuff, right? So it could be that in the real runtime, we use 100. For the test runtime, we use 10, whatever. We can configure it, right? And we'll use some of the exact same things I showed yesterday. One thing we do is this parameter types macro, right? So where we want to generate this get, right? We can basically create this parameter types and then create a constant with that constant value, and it will generate for us this get implementation. Let's see if Keon shows here. And then, of course, inside of your runtime, you can set this thing to this constant. Or you can directly use a constant. So I showed before also this const U32. In the case where you just need a constant U32, you can just directly use this object to then pass that constant in. So both of these things are just equivalent, right? And if you, as I showed you yesterday too, if you really want to be explicit about it, what's happening in the background for both cases is just this. That you said in your palette, I need something which implements get U32. I just need anything. Give me something, right? So if you want to, you can make a struct or an enum or whatever thing that can hold some trait, and then you can implement the trait for it, and then you can pass that object in, right? There's no magic here. It's just Rust, right? I need something that implements this trait. Here's something with that trait. There we go. But the idea is that these other methods are these are objects that already are implemented this thing for you, right? So it's just a little bit easier, less code. But everything in the background is just this. There's no magic. Okay, next, Genesis. So we talked yesterday about the different hooks and how we have access to a Genesis builder, which can actually set up your runtime on block 0. And this Genesis builder is executed when you run tests. When you run tests, the very first time you set up a test, it will run the Genesis. So if you want to have a testing environment where every single time you run the test, that Alice, Bob, and Charlie all have some balance, you can actually set up a Genesis for your balances palette to give balances to all of them. So it can avoid every single time you say, give Alice 100 tokens, whatever you want. You could also, if you want to, just create a function, which is like setup, and then you just call setup at the beginning of every block. But Genesis build, it actually is that hook already into your runtime environment that can do this, right? So if you have a Genesis config in your palette, you can, of course, manipulate and call that Genesis config and run it inside of your palette. And then inside of the testing, you can actually go ahead and access that. So in the testing environment, we'll create a struct builder. Yep, which actually has the content of the stuff you need, right? And some logic in there. And finally, inside of your builder, you call build, you can actually call the Genesis config for each palette. So you can either do default, or you can actually insert your own data, right? You can see that this Genesis config for the template module has the ability to have some fields. You can actually fill those fields in, or you can use the default, right? And then if you actually look inside of your, we have this build and execute, which will actually build, and it will actually call this build function and set up your Genesis. So let me show you that this is already set up inside of your runtime. So we go into our assignment, we go into one of our palettes, test, I told you, you need to use this new test ext. So inside of the tests, I always run my tests within the context of new test externalities, execute with, and then the function. So that's what's happening. What's happening actually is we're setting up our Genesis environment and then calling functions in that context. So if you modify your Genesis, then you're calling functions within that modified Genesis. That's what's happening in those steps. So this is that pattern here, okay? Let me show you another example, maybe with more explicit Genesis. I think if you go into Polkadot SDK, by the way, another thing. A few times, some of you have come up to me and asked questions, and I ask you, hi, do you have the Polkadot SDK cloned on your computer? And you said no. You look at how I do stuff. I literally always have Polkadot SDK open on the side, and I'm referencing it for the answer to my questions, okay? So here, I go to Polkadot SDK, I go to Substrate, I'm gonna go to the balances palette. That's an example. Balances. It also has tests. It has a test environment here. And look at this. If we go down to, oh, where's the mock? Sorry, one second. Where's the mock? Why you have to be like this? I mean, is it the mod? Oh wait, here, let me see. Build. Ext. Oh, here we go. Build and execute with. Let me take this. Okay, maybe the balances palette is a bad example because it's too complicated. Let me do treasury. Treasury has it. Thank you. Thank you. And I just want to mention that I like to use balances because it's the most easy for people to like kind of understand what's going on. But balances palette, because it's so important, like it literally backs billions of dollars. It's like kind of over constructed for safety, right? It's a little bit extra, so it's okay. So inside of here, there is the new FN ext. God, am I crazy? What is it? It's called ext builder. Okay, ext builder. Struct. Okay, struct ext builder. Here, this build. This is basically the same. This is basically the same thing happening. You can follow the patterns here, but you can see here there's a build function. Here, I'm creating this type T. It's mutable. I'm initializing it with the frame system Genesis config, and then I'm creating my balances config in the way I want. So here in this treasury palette, I'm setting up so the balances palette will always give account 0 100, account 198, account 2 1 token. So this I'm giving users tokens at the beginning of my palette, and then I can assimilate this storage into T. So you can see here I have an initial like Genesis, and I'm adding to my Genesis this extra Genesis into T. And I can do that. I can keep assimilating more and more like changes I want. You can even see here, look at this. I'm calling ext execute with set block number 1. This is a way that every single test starts at block 1, so you get events. So rather than you having to call it every single time, you can just do it here, right? And so this means that whenever I call my test, I'll be executing all this logic so that I will have a Genesis with balances, that I will have block number equal 1, and that I'll have any other things I set up in here. Again, this is a little bit advanced. I would say that if this stuff is helpful to you, I can show you how to use it. Otherwise, just you can do all these steps manually inside your test. It's not a problem, right? Okay, let's go back. So this, if you need some help, I'm happy to help you, but basically the code inside of Keon's presentation shows you how to do the same thing. So finally, this kind of combination of tools allows you to actually even make extensible tests. You can actually, with these toolings, create something like this. I have a test here. I have a builder with default, and I even expose functions which allow me to configure those internal setups as I want, right? So I can set up a system where there's voters, add 2 votes with I, add a 3rd voter, right? And then do a bunch of stuff. So you can actually make your testing very, very configurable using these functions you've set yourself up with, right? This is just programming. You can imagine that you can make helper functions and all that kind of stuff. So this is all just programming, accessing the different different paths to update your config. Okay? Yeah, question in the back.
Okay. Can I add like so in the example or in the code it uses, for example, palette balances genesis config. If I need like balances and some data related to my
Yeah, you can put your own Genesis config in here, and you can pass your own data. So if you set up a Genesis config,
yeah, but I want both. So basically, I want balances and I want my own config and have them in
yeah,
in
so
the data.
you just keep assimilating to T. So you could just keep adding to T. So T is mutable, and it's a thing that you just keep putting more Genesis onto, right? So you just keep making blocks assimilate to T. You just keep doing it.
Okay. Yeah. Thank you.
Okay. Okay. You also can, we showed you these parameter types. We showed you that you could configure them as constants, right? What if you actually want to change this constant throughout your test? Like I make a mock runtime, but I want to test different scenarios where the constant is 10, constant is 20, constant is 30. You don't need to create 3 different runtimes. We can actually make this configurable. So in this context, if we go back to parameter types, let's go to the original writing of this. Where's the parameter types? Man, I hate this structure. Up. Okay, if you look back at the slides, there's an original thing, but instead you can put the word static. And when you put the word static, it allows you to actually access this set and get API. And specifically, that when you want to set, you could, in your test function, set the constant to some number you want, and then test all of your tests. So again, you have access to actually change this constant depending on what you want to do in your test. You don't have to make 5 different runtimes. You can actually edit it, right? And this is happening in the background thanks to the parameter types macro. Testing progressing blocks. Okay, so a lot of your different palettes involve some kind of time passing, right? It involves that something initiated here, and I want something to execute or finish at a later block, right? So what does it look like to actually implement time passing in your blockchain? We can fake it in tests. We can actually make things pass. So here's an example of a code block of a very simple next block function, right? Now, there's the most simple case here is you could just call set block number 100 and then call your function, right? But when you do set block number 100, what are you actually doing? You're actually just setting in storage the number 100. You're not actually going through each block, running on initialize, on finalize, all of the hooks, etc., right? So if you actually want to integrate all of the behaviors of block execution, you should create a function like this, next block, where we get the current block number, we call on finalize for the end of that block, then we set the new block number, then we call on initialize for the next block. Right? If this on initialize, on finalize is important for your end-to-end story, unless you call those functions, they're not going to happen. Right? If it's not important, you could just call set block number. Does that make sense? I guess the knowledge you have about the construct runtime, you could even make that even simpler. Instead of calling each palette individually, you could actually just call all palettes and call that function, right? So you have both options available to you. So this is actually a function that you can copy and paste into your code, and then you can call next block, right? So here's an example of a test. You have some initial setup. You execute with. You can do some initial stuff here. Next block. Do some kind of condition here. Next block. Whatever. You can do something like that, right? Just keep progressing. He didn't put this, but obviously you can imagine. So I'll say it myself. Oh, we gotta go back. That you could also make a function called run to block n, right? And then this would basically wrap next block into a for loop and call it until you get to block n. So if I actually go into Polkadot SDK and I search fn run to block, I'm going to find this all over the tests. And look at this. Run to block, assert while n is less than this, go through the block number, call on finalize, set block number, on initialize, or even on idle, whatever hook you need, you do that. So exactly this thing we're teaching you is what we do inside of our tests as well, right? So what I don't want to see is 100 next blocks, please. That's not the way to program. Write some nice code like this, please, okay? And if you need reference to it, you can literally copy and paste this code. It'll work inside your runtime. Nothing about this is unique to this testing environment, right? You may not need this on idle, right? But if you do need on idle, it's there, right? So again, look through Substrate for all of this stuff. Like again, all of this stuff is existing here. Actually, it seems like we could actually use some pull requests to do this better, right? With the all palettes hooks. Okay. It seems like that's the end. So again, this is Keon's presentation. I think, I covered the content hopefully as he intended, but look at the speaker notes, see if there's anything that he included or any references and stuff that might help you here. But really, again, reference the Polkadot SDK as all the different tricks that you can do with test environments. And anything you want to see, ask me. I'll program it live. Yeah.
So in any test, we start with this new test externalities execute with, and
Yep.
if can I add something in the closure inside? Can I call a function that will work on this externality? So I want to extract some common functionalities in my tests
Yeah. So
and call it inside.
let's do exactly that. So this is the basic thing that we've seen. You always call new test X, then you do execute with and some logic. Watch this. I'm going to go into the mock, and in here, what am I going to do? Wait. Okay, I think you need something like this. You need to do, again, this might not compile directly perfectly, but let's try it. Let t equals, and then it goes here. Then I do t dot execute with, and then whatever code I want, to always execute, and then t dot into. Let's see if this compiles. Cargo test palette treasury. Does it make sense what I'm doing here? I'm missing a. No one's paying attention.
Yes, but so what if I want to do this not in the on initialization? I want to do it inside the so we have another execute with in a test, right? With some asserts and stuff, and in the middle I want to call like a common function. Yeah, after the amount, for example, I want to call a common function that will work on like do something with. Yeah.
Sure. I mean, you can just go. Fn do something.
Will it do with the externalities with the actual?
I think it will do it. I think if you like set block number here, like if you do this.
Oh.
I think it'll just work. Let's see. Wait, give me a second. Let's fix this first. So
Yeah.
execute with not found for struct storage and current scope. I think okay. I think I need to do this dot into, and this is going to be a type spio test externalities, and then I do t execute with, and I just return t. It needs to be mute. Okay, let's try this real quick. Great, everything compiled. So 2 things I want to show here. So first is, you had some code. I mean, I'll show you. Let's do the before and after. Before, multisig, source, mock. Before, you had this. All I did was let t equal this with some type, and then I called t.execute with, right? So I really, super simple. I went from this to, where did I just go? Mock. To this, and now I can put some code in here. I could do, for example, in here I could do system set block number 1. And now every single test will start with block number 1, right? So that's one thing you can do. I'll leave this in the code here. The other thing you can do, which I showed and it also compiled fine, is I made a function called do something, which does whatever you want. Like this function can call every single API, can call every single function you can call inside a test, and I just called it. I think maybe your confusion is you haven't seen what happens when you don't call that new test externality. So let me do that. Let's make a new test. So this compile. Let me make sure this compiles one time. It compiles. All right. Let's do a new test. Fn this will fail, and I just call do something. Right? That's an interesting thing, right? It will fail, and you'll see that it will say cannot run tests inside of a non-externality environment. This test panicked. Some call was called outside of an externalities provided environment. Basically, the new test externalities is providing some kind of mock backend that you can store data into and you can call things into. When I call set block number, it is trying to write to storage, but it doesn't have a database backend, right? This is just a basic Rust test. So new test externalities is creating some kind of fake backend that you can access. But once you're inside of this closure, you can do everything, right? So this is the error you'll see. Can we bring the mic to the front? Watch behind you. Or maybe pass it, yeah.
The chair, yeah. Anyways, I don't know if you want to bring this up or like have a quick mention of it in regards to the tests themselves, but if you actually want to handle like whether or not a test asserts okay or asserts with an error, more or less, you have the frame support macros for assert okay and assert no op, basically.
Exactly, right. And I think we went over that mostly in class, but yes. You'll notice that every single one of these calls, I wrap in assert okay, because I expect that the call will execute successfully. And in the case where I think it will fail, I have assert no op, which I call the extrinsic. It asserts two things. It asserts a number of things. It asserts this call will fail, that it will fail with this error, and that it will not change storage. Those are the three things, right? That no op says it does not change storage. No op says that this call will fail, and not only will it fail, but it will fail with that exact error, right? If any of these conditions are not correct, this assert no op will fail. So these are the most common two things you'll use in testing. Assert okay for all the okay cases, assert no op for all the error cases. And I mentioned to you this. When I look for good tests, what do I look for? I look for every single extrinsic. You test every single green case, and you test every single red case. I want to see an assert okay path for every single green case, and that's not good enough. I want assert okay plus a check in storage that the changes you expected happened, right? Why do I want that? I want that because imagine you wrote this function. So here's this function, do something, and this was your thing, right? Like return okay. It's not good enough that your test just saw, oh, it was okay, because here, no logic here is actually executed, right? Some short circuit in the path happened. So it needs to be assert okay, and changes in storage were what I expected. The other thing I want to see is for every single error case, I want to see you trigger that error case with the exact error that you expect, right? Of course, you don't check storage changes there because errors don't change storage. But I want to see that I hit this error, I hit this error, I hit this error, in the way that I expect. This is a very solid basis for a good test. Beyond that, there's more. Beyond that, you might think about things where a combination of extrinsics may put your system in a weird state. But the baseline test is each extrinsic on its own handles as you expect. Okay.
Yeah. And I do want to add to this conversation in regards to checking specific errors in particular, because let's say more or less that a user inputs the wrong, like let's say for the multisig, for instance, the user inserts the incorrect wallet address for the multisig wallet, then the error should be specifically about the fact that the wallet account ID is invalid, more or less, or
So I think you're saying you should have a number of errors which are verbose to the exact error that's happening, right?
Correct, for
Yes.
the purposes of having proper
Right.
UI UX.
Do not. So I absolutely agree with that. Do not go here and say, oopsie, whatever, and then use that for every function. That is not helpful. Every single possible error should pretty much have a unique error type, right? Yeah. Okay, that's all great stuff. Okay, so